in multiple ways, multiple dimensions, whether it is working properly or not. Then after it will go to the production environment, right? This is the developers can code, develop the code, and after that it is go to stage level like testing environment. Testers will work. Then after it will move to the production environment. Okay. So now developing the code, and after that it is testing the code. And if anything is something went wrong, then immediately testers will go back to the developers and fix the bug, and immediately it will send to the testers again, starting the testing, and again they are facing the issues, or completely test is over completely and it is fine, application is fine. So after that it will go to the production. It will take 3 to 6 months in earlier days, right? Before the DevOps, usually it will take 3 to 6 months. So it's yearly, maybe we will release like every application can be released 2 versions or 3 releases, 4 releases will be there in the olden days, because the process of the application deploying in the production, there is a huge time. It will take a lot of time to develop the code. So developing the code maybe it might have take time. That's not a problem, because developers has to get the thoughts and they has to create their own application like based on the requirement. It may be take a time, but after that there is a process to deploy your application in the production environment. There is a process. Okay, you know the path. So how that process will be completed? How much speed you are? Okay, how much time it is taking to complete the process? That is very important. So developing the application may take time. That's not a problem. But once after created or once after developing the application to go to the production environment, that is called process. That process should be simplified. In earlier days, it will take more time, right? So that is what. How can we simplify this process? Because we have the application, completely, and it is working fine. So to go to the production environment, it has taken more time. So that's the reason why how can we simplify this time, this process? So there, DevOps is helping us. Actually, DevOps will help you. So this is the DevOps. For developers also, we need to give some environment. For testers also, as the operation team, for testers also we have to provide some environment, and production also we have to provide some environment. There we can deploy our application. So that is usually it is taking more time. So that is the problem. To overcome that problem, there is a DevOps placed. So now developers can create the code and push to the production environment. No, sorry, developers can create the code and they will do some operations, some process to whether it is working or not in their environment. Okay. Then testers also then move to the testing environment, and testers also will do the testing whether the application is working or not properly in the multiple dimensions. Okay. So that also they are also having some code. So this code, developers can create the code to develop the application, and the testers also create some code to testing the uh, automating to automating to test your application. So they have their own codes, but how can we simplify that? So there, DevOps is the place. DevOps is come to the picture. DevOps will help to the developer to do the process in very less time. Like, so developers knows already the application, and making that application up, they need some process, some task will be there. So those tasks we have to complete as a DevOps engineer. So partial, we are not a complete developers, but partially we can do the developers work. And also we are not a testers, we are not a complete testers, but partially we can do the testing environment works also. So that is called DevOps actually, which means developers whatever the code they are developing, and developers job partially we are doing, and operations team like testing or production support, whatever it is, that is called operations team. So operations work also we are doing partial. So that is what we are call it as a DevOps. Okay, we are call it as a DevOps. we are doing the operations teamwork and developers teamwork. Developers can create the code, but after that, what they are doing, those tasks we are completing. So simply they are developing the code and committing. Simple. So after that, whatever the testing and artifacting, creating the artifacts or build, testing and deploying the code, and everything can do by the DevOps engineer. And also testers also they're having their own code to test the application, everything. So they will create that code and they will give the code to us. So we will simplify. How can we test automatically? Like uh, creating the CI/CD pipelines. So once after commit happened from the testing environment, then immediately what they are doing manually, those we can do the automate to testing the application. So that also we can done. So this is the DevOps. Actually, there are multiple tools or there behind the DevOps to run your application or to push your application to the production environment. So from the developing and pushing that application to the production environment, in between of that, so many tasks has to be complete. Otherwise, the application will never come to the production environment. So what are the tasks are going to done in between of that developing and production environment? So those tasks we are doing in between of developers and production environment. So that is our job actually as a DevOps engineer. So here, what are the tools we are going to learn? What are the tools we are going to learn here? That is very important. So any doubts still here? We are not a complete developers, but partially we are doing the developers job. We are not a complete testers, but partially we are doing the testing environment. We are completely operations team, like provisioning the infrastructure, provisioning the servers, and giving the space to run the applications. This and all we are doing. Apart from that, we are doing the partially the developers duty and also testers duty. So that we are configuring in the CI/CD pipelines, whatever it is, whatever the tools you are using, those tools will take a place here. So what type of tools we are going to learn here, that we will discuss. So now as a DevOps engineer, you understand or not? What if you have any doubts here, you can ask me now.
Oh, no.
Now, so now what are the tools we are going to learn? So first of all, if you want to run your application, for suppose if you want to run WhatsApp in your mobile, okay. So what is required in your mobile first? For suppose if it is a RAM mobile, there is no operating system inside of your mobile. Can you run any application inside of your mobile? WhatsApp application will run without operating system. So what type of what type of operating system you are using in your mobile?
Android or iOS.
Yes, correct. So Android or something like Mac or whatever it is, you are using Android. For suppose if you are using Android mobile, there is Android is already installed. So because of the Android, your applications are running on top of your mobile. So whatever the application, WhatsApp, Facebook, Gmail, so many applications you are installing in your mobile and using your applications, right? So how without Android can you run your application? No, you cannot run, right? So in here also, if you want to run your application in your environment, definitely you have to install provision your server like with operating system. So what type of operating systems are there? Windows are there, Linux are there, Solaris is there. So different types of Mac also one of the operating systems. So different types of operating systems are there. But here we are learning Unix flavors. Unix flavor like Linux. So 80% of the applications in the real time in our real time environment or industry standards, they are using the Red Hat Linux or Ubuntu or something. Okay? So that is the reason why first of all we are going to learn Linux. First tool we are going to learn Linux because Linux basics at least admin level is required to learn because your application is running on top of the Linux server, right? So that 1 minute, guys. 1 minute. 1 minute, guys.
Okay.
Guys, you can mute yourself. If you have any doubts, you can unmute. Okay, it's making disturbance to others. Thanks. So Linux. So here we are going to learn Linux. Even Windows operating systems are there, and different types of operating systems are there. But now widely industries are using the Linux, like Red Hat Linux or Ubuntu. So on top of that only your application is running. So that is the reason why we are going to learn Linux. Okay. So after that, where your application is, you want to provision, like your application, you want to deploy your application on top of the Linux. So Linux bare metal machine you are using, or different types of nodes are there, Linux nodes, like bare metal machine, or you can use the VMs, or you can use the containers. So what is the differentiation between them? Where you can use the bare metal machine, where you can use the VMs, or you can use the containers, right? So bare metal machine is one physical machine, you can add RAM here. Okay, RAM, and whatever it is space, like data, uh, what we can call ROM, ROM. So everything resources, what are the required resources are needed to provision your bare metal machine, those can be attached as a hardware, and you can provision your machine, bare metal machine. So if you deploying the your application on top of the bare metal machine, this is the physical machine. Bare metal machine is physical machine. On top of the physical machine, if something happened to the your bare metal machine, then everything is gone. And one more thing, if you want to provision the copy of the bare metal machine, like same bare metal machine, one more bare metal machine is required to run your application, because for high availability, of your application, you need a one more machine. To provision one more machine and adding the resources, everything, and creating the new mission, so it will take huge time to provision your bare metal machine. It will take a lot of time and a lot of resources it can be used, and scaling up and scaling down is a little difficult. Little, not little, it's highly difficult. So many disadvantages are there to run your application on top of the bare metal machine. Okay, bare metal machine, physical machine. So that is the reason why, to overcome these problems, VMs comes to the picture. VMs, virtual machines. So now virtual machines, so many years of time, virtual machines work very well. So virtual machines means your bare metal machine will be there, based on your resources. Resources means RAM, processor, CPU cores. These are called resources. Based on your resources, multiple virtual machines you can deploy on top of this. Multiple virtual machines you can deploy on top of this. So this is called your bare metal machine only. But on top, but here you are installed any one of virtual machines, like Oracle virtual machine, or virtual machine, some type of virtual machines will there. So many hypervisors are there. You can install whatever the hypervisor. Hypervisor is your bare metal machine and your virtual machine. In between of that, hypervisor will be there. Hypervisor will help you to use the resources, base machine resources, to the virtual machine. So there, in between of that, there is a hypervisor. We can call this as hypervisor. Now high availability of your application little increased, because your application you can deploy in the multiple machines, right? In earlier, if you are deploying your application on top of the bare metal machine, then creating the same replica of the bare metal machine, it will take long time and resources also usually and high budget. So many disadvantages are to deploy your application on top of the bare metal machine. So to overcome that, we are using the virtual machines. So virtual machines means just resources are there. How many resources in our bare metal machine? Resources are there. By using the resources, we can create or provision multiple virtual machines in isolated environment. So this is one node. This is one node, node 1, node 2, node 3, node 4, node 5, like that. So many nodes you can create. So in your application, you can deploy in the multiple nodes, no problem. So then there is a high availability. So one node gone, for suppose this node gone, no problem. Next node will be serve your application, right? So that is the advantages of that. But now here also some disadvantages are there, because each and every node to provision there is a OS. There is a OS. There is a OS, right? OS is required for each and every virtual machine. There is a OS. So wherever you are seeing like OS, then obviously there is a booting procedure. So wherever you are watching the booting procedure, which means to provision your system, there is a grace period of time to provision, to make up, to provision your system. So there is a grace period because first of all, OS is booting up, like booting procedure will be there. OS should be come up, then after your application will be run. So to provision, if you are scale up the virtual machine, then first OS will be provision, right? OS will be provision. After that, your application will be active. So this will take some time. This will take some time. Sorry. So for suppose bare metal machine will take to provision 20 minutes, virtual machine will take 10 minutes. Okay, 10 minutes. So now if you want to establish the bare metal machine, create the one bare metal machine and provision the bare metal machine and installing the operating system on top of that, maybe it will take 1 hour to 2 hours. Virtual machines are a little reduced. Like to provision virtual machine, to create the virtual machine with OS, it will take 30 minutes. So after that, once after you created the virtual machine, you can restart the virtual machine. The restart time, like there is a grace period like 10 minutes or 5 minutes, something will be there, because it will take little minutes, like 5 to 10 minutes it will take to provision virtual machine, because there is a OS is there. And one more thing, creating the virtual machine, there is a minimum resources are required, like 2 GB RAM, 20 GB of space, 4 CPU cores. That minimum requirements are there to provision your virtual machine. So because of that, the budget will be high, and spin up and scaling up and scaling down your virtual machines also, it will take little time. Okay, it will take little time. And your node 1 is using Linux, node 2 is using the Ubuntu machine, node 3 it is using the Fedora machine. So different types of OSs will be used, but application may work on the Linux machine. On top of the Linux machine, it may not work on the Fedora. There is a little changes will be there. So version compatibility issues also will come. And one more thing, for suppose you are installing the Python here, Python 1.2. Okay, Python 1.2 version. Python 2 version you cannot install in on top of this machine, because any one of the version only will run. If you want to run the Python 2, then you have to provision one more system and create the Python 2. And one more thing, your application may be work on top of the Python 2, it will not work on top of the Python 1. So like that, so many version compatibility issues are there. Only because of the version compatibility, to overcome this version compatibility, there is a containers. And to overcome to provision your system, it will usually it will take little time. Okay, so to reduce the time, booting procedures, scaling up and scaling down, to reduce that time of scaling up, containers are comes to the picture. So to overcome these many disadvantages are there. Even many years of we were used this virtual machines in many years. Still, they are not fully satisfying the vendors like our companies or organizations. VMs are working properly, no problem. VMs are very helpful for after when compared to the bare metal machine, but it is not fully satisfying because your application need to run your application. It's needed only 1 GB of RAM and 2 GB of memory. Okay, so like that very small application you want to run with limited resources, very limited resources. So to providing the limited resources to your application is not possible by the virtual machines, because to provision virtual machine minimum resources are required, like 20 GB of RAM, ROM, and 2 GB of or 4 GB of RAM, CPU cores and processor. Minimum things are required. It is virtually it is using, because of that we are saying like virtual machines. So these minimum resources are required. So your application, that many resources are not required to run your application, because your application is very small. So why this much of spaces are required? This much of resources are required? Not required. So to provision a virtual machine, for high availability, two, three virtual machines are required. 2, 3 virtual machines also using the same resources. Like what are the minimum requirements are there na, to provision your virtual machine? To minimum resources are they are using, but those many resources are not required to run your application. For high availability also we are provisioning the system, same system, but that much of space is not required to run your application. That is the problem. So budget will be little high, little high. So compared to the bare metal machine, it is less, but still budget is high, because 1 GB of RAM is required to run your application, but still 4 GB of RAM is there inside of the VM. So what is the 3 GB of RAM? What is the use of 3 GB of RAM? So now for a high availability, you are running your application on top of the 3 nodes. On top of the 3 nodes. So 3 nodes means 3 are 9 GB of space is waste. So this is the purely disadvantage of your VMs. So that is the reason why to overcome that, containers are comes to the picture. Now in DevOps, 5 years back or 6 years back, there is no containers concept in the DevOps. Till virtual machines only. On top of the virtual machines, we are working. So now, where your application is running, that is important. In your organization, your application is running on top of the instances like AWS, then AWS is fine. But suppose your application is running on top of the VMs, till VMs is fine. But suppose your application is running on top of the containers, then you have to learn the Docker and Kubernetes. For suppose if your application is running on top of the virtual machines, then Linux is enough. But your application is running on top of the containers, then definitely you have to learn Docker and Kubernetes. Docker. So now containers. What is the use of the containers? What are the disadvantages till now we discuss? Those disadvantages will be overcome. How it will be overcome? That we will discuss in the Docker. So now most of the organizations are using containers to run their applications. 80% of 80 or 90% of organizations and industries in the real time, they are using the Docker containers. So different type of container tools are there. Container CRIO or container D, container D. Like the Docker, different types of container engines are there. Container runtime, we can call them as a container runtime. Mostly widely and mostly we are using the Docker. So that's what we are going to learn the Docker here. Okay. Then to manage the containers. So multiple containers are there. There is a Docker swarm to manage your containers to replica, scaling up and scaling down. Okay. and based on your requirement, how can we deploy the application on top of the different type of containers to scale up, to replicas, maintain the replicas, and managing this in the same network, all the replicas. So to managing the containers, you can create the container by using the Docker. So to manage the containers, how can it is possible? So by using the Kubernetes, we are going to learn the Kubernetes as well. Kubernetes is an orchestration tool which help you to manage the containers. In the Docker itself, there is a Docker Swarm. That is also one of the orchestration tool. But so many, very few features are there in the Docker Swarm, and Kubernetes has more features. And Kubernetes is using by multiple organizations in the real time. So that is the reason why Kubernetes is very important nowadays. As much as importance we are giving to the containers, Docker, more than that, that much importance we have to give the Kubernetes, because Kubernetes is helping us to manage the containers. How can we manage the containers? Kubernetes does not create the container. Kubernetes doesn't know what is the container, but Kubernetes can manage the containers. How can they manage the containers? We will discuss in the Kubernetes. Okay. So now, so developers are creating the code. Developers are creating the code. So Linux, Docker, Kubernetes. Why we are going to learn? I already discussed, and we are going to discuss about the version control system called Git. One is Git. So how can we track the code? So whenever the commit is happen automatically build and deploy and testing and deploying into the production environment, everything should be done once after committed from the developer side. So these commits will be happen, and tracking your code, or any changes are happened in the code, immediately it should be find, and it should be maintain the history of the versions, history of the commits can be done by the Git. So Git is a version control system. It can track the code, how many commits are happened, how many changes are happened, how many releases are happened, what is the differentiation between the previous release and present release, what is the differentiations of the previous version and present version, versions history, everything can be managed by the Git. Okay, there is a different Git bucket, big bucket, so different types of tools are there, but Git is open source and widely Git they are using. Git and GitHub also we will learn. GitHub also we can learn. Nothing is Git. Git means it is a CLI. GitHub means it is a user interface. So how can we push the code into the GitHub? It is a distributed environment. Okay, so that's the reason why we are going to learn the Git to manage and to track your code, developer's code or tester code, whatever it is. So once commit happened from the developer side, immediately it should be build the code and deploy the code and test the code and everything. It should be fine. If it is a find any bug, then immediately it will notify back to the developers. So first of all, this process should be happened by using the GitHub and Jenkins. So now here we are going to learn Jenkins also. So as a DevOps engineer, so mostly and mainly we have to focus on top of the Jenkins, because CI/CD pipeline is their continuous integration and continuous deployment and delivery. So how it will be happen? Okay, so once after commit happen from the developer side, Jenkins will be identify that commit. Immediately start the build, start the testing, and start the deploying your application. Everything can be done by the Jenkins. So Jenkins can automate your work. Jenkins can automate developers' work partially, because Jenkins cannot create the code. But after creating the code by the developer, then how can we simplify their work? How can we simplify their process of work? after creating the code. That can be done by the Jenkins. So now here, and also testers job also can do by Jenkins. Testers can create the code. Testers can create the code to test your application, and after that there is a process. So that code, we can take that code and place that code inside of the Jenkins. So Jenkins can automate the manual work of the testers. Jenkins can automate the developers work. Okay, Jenkins can automate the developers work. So that's the reason why we are using the Jenkins. Jenkins, we have to give the more importance in Jenkins, because everything is integrated with the Jenkins in Docker, Kubernetes, Git, Linux. So everything can be integrated with the Jenkins. Center point is the Jenkins. So that's the reason why we are going to learn the Jenkins as well. So now Maven. So Maven, actually Java developers can use widely. But here also we have to create some artifacts. So the WAR files and jar files. Once after they are creating the code, on top of that we have to create the artifacts and store the artifacts in the JFrog. Okay, there is an artifact storing tool is there like a JFrog. So that's what we have to push, and we have to create the builds by using the Maven. So Maven also will be integrated with the Jenkins. Maven also can be integrated with the Jenkins. So by default, there is a different types of tools are there to integrate with the Jenkins, like a Git, like Maven, or some other tools. There is a plugins actually. Plugins are there. By using the plugins, we can integrate. We can integrate with the Jenkins. Docker has their own plugins, and Kubernetes has their own plugins to integrate with the Jenkins. And Git by default, while you are installing the Jenkins itself, Git plugins are there. Automatically it will be installed and it will be integrated. So Maven also one of the tool which can help you to build the artifacts. Okay, Maven also we are going to learn. So now very important tools are there. So where you are creating your infrastructure, on premises or cloud, on premises or cloud. So where you want to provision your systems and where you want to deploy your application, that is very important. So now here, on premises means just data centers are there. There we will create the virtual machines. On top of that we can use. So here now in the real time, most of the companies or most of the organizations, they are using the AWS cloud providers like Azure, AWS, or GCP. So like that. So now we will record, no problem. From tomorrow onwards, the sessions we will be record. Today I'm not recording because it is a demo what we are going to learn in these sessions. Okay. So now where you want to run your application, but infrastructure you have to provide now. So that's the reason why we are going to learn AWS as well. One of the cloud provider it is AWS. AWS we are going to learn here. AWS will help you to create the instances, and on top of that we are going to run your application. Okay, so that's the reason why we are going to the cloud provider called AWS also we are going to learn. And 81 is Ansible. So Ansible is a configuration as a code. So what is the meaning of the configuration? So now here I am removing this. I'm simplifying this is very important tool it is. Ansible is a configuration as a code. For suppose you have a multiple nodes like node 1, node 2, node 3, node 5. So like this, so many nodes are there. 60 nodes in your cluster. You are having minimum 60 nodes to the 500 nodes. Okay, 500 nodes. Some configuration change is required. So currently Python 2 is running on top of your nodes. Python 3 you want to change. Python 2 you want to upgrade. So if you want to upgrade in the multiple missions, manually if you are doing it will take long time, like a huge time it will take, and it is manual interaction and manual deploying your upgrade manually. If you want to upgrade the Python or whatever it is, that is very risky and it will take huge time, right? So configuration as a code by using the Ansible, just you can upgrade your configuration file of the Ansible file like a playbook. Then you can push the playbook immediately. All the nodes like 60 nodes or 70 nodes or 80 nodes, hundreds of nodes are there. So everything can be upgraded. Upgrading will be started immediately parallelly, not sequentially, not one by one, parallelly. And each and every node, for suppose 60 nodes are there in our cluster, in 60 nodes at the same time upgradation will be started, Python 1 to Python 2. So that is the configuration as a code to apply the new configurations or new packages or new changes in your nodes, not the containers, guys. Here, not in the containers, in your nodes. In your nodes means servers. So if you want to change the configuration, or if you want to update the configuration and upgrade the systems or patching, whatever it is, if you want to do in the multiple systems, then we can use the Ansible configuration as a code. It is a configuration as a code. Configuration as a code. So there are multiple tools are there like Pipette, Chuff, and different types of tools are there. But Puppet and Chuff, we have to install the agent in each and every node. So installing the agent, for suppose new node is added to the cluster, immediately we have to install the agent. Which agent? Chuff agent or Puppet agent. So configuration to installing the Puppet and Chuff, it is a little difficult when compared to the Ansible. So Ansible is no need to install the agent in each and every node. So Ansible server will be there. There is an inventory file. Then whatever the nodes you are added to the inventory file, then all the nodes will be comes under the Ansible. So you can operate all the nodes from the Ansible server. So there is no agent or something else. Okay, it is very easy to installing the Ansible, and usage also very much easy when compared to the Chuff or Puppet. Okay, that is called configuration as a code. We are going to learn here. And ninth one is Terraform. Terraform is a very important tool nowadays, widely in the real time organizations. In our organizations, they are using the Terraform. Terraform is a infrastructure as a code. Infrastructure as a code. So now you are already having the nodes here. No, Ansible is a configuration as a code which is helping to upgrade your existing nodes. Existing nodes, which means already running the nodes. Already running the nodes. If you want to do something inside of the running nodes, then you can use the Ansible. So that running nodes, how can you provision? How can you set up the environment? How can you set up the infrastructure? So now,
recording in progress.
See here, I'm removing this. There is a cluster. You want to create the multiple nodes like see here, like this. This is the cluster environment. Here you want to provision the 60 nodes. 60 nodes. If you want to provision 60 virtual machines manually, it is taking more time. Okay, highly. So many employees has to be work on top of this to provision multiple nodes. So now, simply I want to write a one script and start the script immediately based on the script. Immediately new virtual machines or virtual nodes has to be provisioned. So there we can use the Terraform code. Terraform is a infrastructure as a code which can help you to provision the multiple nodes. Provisioning, that is called infrastructure. So Ansible will help you to configure the new changes on top of the existing nodes. Ansible will help you to install or changes or upgrading the patching or upgrading the versions or patching on top of the existing nodes. So that existing nodes, how they are provisioning. So Ansible will not provision your server. Ansible will not boot up your server. Ansible will help you to do some changes in configurations in your worker node or master node, whatever it is. That is called, because that's what we are saying. Ansible is a configuration as a code, but Terraform is a infrastructure as a code. How can you provision? So if you are not provisioning your servers, there is no use of the Ansible. If you are not provisioning your servers, there is no use of the Kubernetes. There is no, how can you use that? Docker, Kubernetes, Jenkins. So if you are not ready with your infrastructure, there is no use of all these tools. So first of all, you need to set up your infrastructure. Okay. To set up the infrastructure, we can use the Terraform. Terraform is widely they are using now in our organizations to provision your servers. So that is called infrastructure as a code. So we are going to learn the Terraform as well. Okay. These are the tools we are going to learn, and monitoring tools like Grafana, Prometheus also. 10th one is, sorry, Grafana and Prometheus. Monitoring tools, okay, to monitor your cluster, complete cluster, to monitor your applications, fetching the metrics and displaying the metrics trend, traffic trend, everything we can monitor by using the Grafana and Prometheus. These are the tools mainly we are covering as a DevOps engineer. So now, personally, I am saying, if you are completely learn this course, only Docker and Kubernetes and Linux. Okay, there is many more job opportunities. Only CI/CD tool like Jenkins, Git, and Linux, there is jobs. Only on AWS and Linux, there is a jobs. Many jobs. Only on Terraform, there is a multiple jobs. So totally we are learning as a DevOps engineer all these tools. So if you are having the if you are placing these many tools on top of your resume, then weightage of your resume will be increased. You will get the many calls. That is for sure. So now your turn. You can ask me the questions, whatever it is. So this course will take 2 months, guys. Minimum 2 months. Because Linux will take 6 days. Docker will take 6 days. 4 to 6 days. Kubernetes will take 10 classes. GitHub will take 2-3 classes. Jenkins will take 3 classes. Maven only 1 class. AWS will take 2 weeks. Ansible will take 1 week. Terraform will take 1 week. Grafana Prometheus 1 day only. So total 2 months course to this. So now your turn. You can ask me any questions. If you if all the people, all the engineers, all the students are from the Telugu, then we will discuss in the Telugu also, no problem. If anyone is there who doesn't understand the Telugu, then we can continue the classes in the English only. Okay. So now you can ask me questions. Any doubts?
Hello.
Yes. Yes, you can ask me.
Hello.
Yes.
ఇది Ansible రన్ చేయడానికి ఇది క్లస్టర్ అనేది క్లస్టర్ కానీ క్లౌడ్ కానీ మ్యానిటరీ అండి, లేదంటే VMs మీద కూడా రన్ చేయొచ్చా Ansible
VMs మీద కూడా రన్ చేయొచ్చు. VMs మీద bare metal machines మీద రన్ చేయొచ్చు. VMs మీద రన్ చేయొచ్చు. యాక్చువల్ నోట్స్ నువ్వు ఎక్కడైతే ఉన్నాయో ఇప్పుడు డేటా ఆన్ ప్రెమిసెస్ నోట్స్ కానీ క్రియేట్ చేసావు అనుకో, VMs మీద Ansible స్క్రిప్ట్ రన్ అవుతుంది. లేకపోతే